Hey guys, how you doing? This is Coach Scott, and real quick, wanted to add to some of the videos we have. We're talking about double and triple bonds, and again, just your basic Lewis structure. You'll play with it, and it'll just work, right? So, if we've used all the electrons, all right, before the central atom has an octet, all right, then we're going to form multiple bonds until that central atom is seeing 8 electrons or an octet. Like here we go with hydrogen cyanide. The nitrogen is going to give up pairs until that carbon has 8 bonds around it, or 8 electrons. So atoms are going to form double or triple covalent bonds if they need those to attain a full energy shell because they're sharing 2 pairs or 3 pairs of electrons instead of 1 pair. A bond that involves 2 shear pairs of electrons is what we call a double covalent bond. If a bond formed by sharing 3 pairs is called a triple bond. All right, so these bonds, they start to shorten as you add more bonds to there because, well, they're having to fold on to each other, right? So if we add additional bonds, it's going to decrease the length of the bonds. So that means that triple bonds are shorter than double bonds. Makes sense. And these are shorter than single bonds. Here's some examples. There's a carbon-carbon single bond. It's got a length of 1.54 angstroms. Or if you look at a carbon triple bond, right, you got a 1.20 angstrom length, much shorter. Carbon nitrogen bond, one CN bond is 1.43. A carbon triple bond nitrogen is 1.16. So much different. All right. Also, the energy is increases as you form more bonds. If you've got a triple bond carbon, the energy, right, that's needed to break those double and triple bonds really increases a bunch. It goes from like a single bond carbon to 350, 348 kilojoules to like 839 kilojoules. That's a lot of energy. And when they break those bonds, they're going to release that energy. Okay? So triple bonds are the strongest of the three. Makes sense. So how do we do this, right? So first we got to figure out our valence electrons. All right, carbon dioxide, CO2. Well, I've got one carbon bond or one carbon atom. There's 4 valence electrons for that. Then I have 2 oxygens, so there's 6 in oxygen. So that's 4 plus 12 equals 16 electrons. So first I'm going to form my single bonds. See, I do that with carbon. I have a single bond oxygen carbon bond right there. All right. So let's see, there's 4 electrons I've used. Then I'm going to put lone pair around all the oxygen until there's 8 around the outer electrons, or outer atoms rather. So there's 2, 4, 6, 8. Oxygen's happy. 2, 4, 6, 8. That oxygen's happy. Now, if I look at my carbon, all right, we've only got 16 electrons, and we used them all up. Carbon is not happy. There's 2, 4. There's no 8. So, since it does not have enough, we're going to move one of those pair between the carbon and the oxygen, and it's going to form a bond, a double bond, right, between the carbon and oxygen. And we'll have to do one on this one too in order to get the 8 electrons that carbon needs. So now I've got 2 lone pair, all right, around that oxygen, 2 lone pair around that oxygen, and carbon is sharing those electrons, okay, with the oxygen. So now it also has 8 electrons around it. Everybody's happy. And we're using 16 electrons. 2, 4, 6, 8, 10, 12, 14, 16. Man, we're all happy. All right. So we were going to do oxygen. Let's see if I can do this. I bring oxygen down here, right? Another oxygen down here. Okay, so I'm going to draw let's see, a bond between oxygen and oxygen. And of course I see, let's see, oxygen's got 6, there's 2 oxygens, I've got 12 I can fool with, 12 electrons. So I've got 2 right there. Let's start doing now some of these. Alright, we got to do some lone pair. Alright, I'm going to put some lone pair there, lone pair there, lone pair there. Again, we've got 12 electrons we can fool with, 6 and 6. Alright, so cool so far. There's 6, 8, there's 6, there's 8. I got, what, 4 more. Alright, ooh. Okay. There's 10. There's 12. Okay, I've used all my electrons. Alright, 12. 2, 4, 6, 8, 10, 12. Okay, and I don't have that oxygen happy. So what I'm going to do is take those 2 electrons and move them down there. I'll just move that up there. Alright, get rid of that. So now I'm going to here, see if that works. Right there. Alright, so I've got 2 electrons on there, 2 there, 2, 4, 6, 8. That oxygen is happy. 2, 4, 6, 8. That oxygen is happy. I've used 12. 2, 4, 6, 8, 10, 12. That one's happy. We're going to practice some of these. There we go. There's as we go. Alright, we notice nitrogen, and after you do it, you'll see that it's got a triple bond. Carbon monoxide, you'll find that that has a triple bond also. And practice these. Alright, so as we look at these, and if we look at all of these, alright, we see that these are, well, one, they're diatomic. They're always found in nature, right? So there's 7 of these, right? 7. Now 6 of them, of the 7, 6 of the 7 form a 7 over here. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, the halides, right? Hydrogen sits up there. But these are always found in nature. And you'll find after you fool with them that hydrogen, of course, it only has a single bond, so it'll be H2. Nitrogen has a triple bond, N2. Oxygen has a double bond, and you'll find that halogens, fluorine, chlorine, bromine, iodine, are all singly bonded. And we'll play with those in class so you can figure it out. But these 7, all right, 6 of them, all right, form a 7. Yeah, that was a joke. Okay, and of course we come to our questions, and our next video will be on polyatomic ions. So this is Coach Scott saying, see you guys later.